In this lesson, we're going to continue talking about factoring, but we're going to look at some special patterns that can be used when we have two terms. So we've already learned how to factor 4 terms, that's grouping. 3 terms, we had lots of methods, including trial and error and the AC method. And so in this lesson, we're going to look at things with 2 terms. And so first of all, I want to remind you of a pattern that occurs when you multiply or FOIL something out where the signs are opposite. So let's say we have x plus 5 and then an x minus 5. When we use FOIL, our first is x squared, our outer is minus 5x, our inner is plus 5x, and our last is minus 25. Then when we combine like terms, the inner and outer terms cancel out, and we're left with just x squared minus 25. This is sometimes called the difference of squares pattern, and I have it written above, which basically says if we want to factor something that is a difference of 2 perfect squares, we will always get a plus b times a minus b. And it really is the same multiplication idea, just kind of written in the opposite form. So for example, to factor x squared minus 49, I know that 49 is 7 squared, so this would be x plus 7, x minus 7. That's just using that pattern. Or 4y squared minus 25. Well, 4 is the same as 2 squared. So I've got 2y squared minus 5 squared. That can be factored as 2y plus 5, 2y minus 5. Just like in the previous sections as well, we can't forget to look for GCFs. And so part C, 2y cubed minus 8y. As is, those are not perfect squares. 8 is not a perfect square. 2 is not a perfect square. But this problem does have a greatest common factor, GCF. You can take a 2 and a y out of both terms. And then you're left with y squared minus 4. Oh, and now that is a difference of squares. The 2y would stay, and y squared minus 4 becomes y plus 2 times y minus 2. Example D doesn't have a GCF, but this one is also a difference of perfect squares. X to the 4th is the same as x squared squared, and 16 is 4 squared. So using that pattern, we can factor that as x squared plus 4, x squared minus 4. And we can actually go even further with this problem because this x squared minus 4 is also a difference of squares. We can't factor the x squared plus 4 any further. There is no formula for a sum of squares. So I'm just going to copy down the x squared plus 4, but then this x squared minus 4 can be factored as x plus 2, x minus 2. And that's my final answer. So again, x to the 4th is the same as x squared squared, and that's why I was able to factor this one with that exact same pattern. Now there's also a pattern for factoring both a sum and a difference of perfect cubes. I have the formulas circled in blue, and these are formulas that you actually don't need to memorize. I'll give these to you on exams, but make sure you have them in your notes somewhere because you'll definitely need to use them on the homework. So basically, these formulas work anytime you have a sum or a difference of perfect cubes, and so I guess maybe we should write out what do we even mean by a perfect cube. Well, 1 to the 3rd is 1, 2 to the 3rd is 2, no, 2 to the 3rd, sorry, is 2 times 2 times 2, or 8. 3 to the 3rd means you have 3 3s, so 27. 4 to the 3rd is 4 times 4 times 4, or 64. Those are some examples of perfect cubes. So when we see a sum or a difference of perfect cubes, we can actually factor it using these formulas. So in example A, I have x to the third plus 8, which we just figured out was 2 to the third. So using this pattern, now I'll use the second one because there's a plus sign. I'm going to replace all the a's with x's, and I'll replace all the b's with 2's. So that means we can factor this as, again, I'm using this pattern right here, second one. So we can factor this as, let's see, it's a plus b, so x plus 2 times x squared minus x times 2 plus 2 squared. And then I'm just going to rewrite that so it looks a little bit nicer. Now I've got x plus 2 times x squared minus 2x plus 4. And that's my final answer. I actually can't go any further with this. When you use these cube formulas, you'll never be able to go any further. You can try to factor that trinomial, but product of 4, sum of negative 2, you won't be able to do it. So there's my final answer. All right, let's do 2 more. 54 is not a perfect cube, and neither is 2, but this problem has a greatest common factor of 2. And so if I pull the 2 out, now I've got y cubed minus 27. And 27 is a perfect cube. We have a y cubed minus 3 cubed. So using that pattern, this time we'll do the a cubed minus b cubed pattern. And so I'll just rewrite it quickly. This should be the same formula I had typed out in your notes. So the a is going to be y, and the b is going to be 3. We'll also make sure we keep that 2, that GCF, in our final answer. So I'm going to keep the 2 there, and then a minus b should be y minus 3, and then we get y squared plus y times 3. I'll write that as 3y, and then plus 3 squared, I'm going to write that as 9. And there's my final answer. All right, last one. In this one, both 8 and 27 are perfect cubes. This is the same thing as 2p to the third minus 3 to the third. So that means the a is 2p and the b will be 3. And let's use that pattern in red. So this should be a minus b, so 2p minus 3, and then a squared. So we're going to have to square that entire quantity, both the 2 and the p. And then it's plus 2p times 3 plus 3 squared. All right, so that's 2p minus 3. And then 2 squared is 4, so this is going to be 4p squared. And the middle term should be a 6p plus 9. And that's my final answer. It's really easy to forget to square that 2. So sometimes when I'm doing these problems, I finish them by checking just the first 2 terms. So the 2p times the 4p squared should give me the 8p cubed. And then I check the last 2 terms only. So the minus 3 and the plus 9, minus 3 times plus 9 does give me the minus 27. Turns out when you multiply it out, everything else cancels out. And so I do trust that I have the formula correct, but usually just checking the first and the last is enough to catch any of those kind of common mistakes. So now that we've talked about all of our different factoring methods, let's just do a quick review and talk about some kind of general strategies for when you're taking an exam and your factoring problems are all mixed together. So the very first thing you want to do in any factoring problem is look for that greatest common factor. That should always be step 1. Is there a greatest common factor? And then you can pick the method based on the number of terms. If your problem has 4 terms, we're going to use that grouping method. 3 terms, you can pick trial and error or the AC method. 2 terms, you're going to use a formula. And by formula, I mean those difference of squares or difference of cubes or sum of cubes. So let's try some examples. So factor each expression completely. The very first thing I'm going to do is look for a GCF. And so, I can definitely take out a 3, and I can also take out an x. And then I'm left with x to the third plus 8. Now I have only 2 terms, so I can only factor this if it fits into a pattern. And this does fit into a pattern. This is a sum of cubes because 8 is the same thing as 2 cubed. And so I can use the sum of cubes formula. And so I'm going to copy down the GCF. The 3x doesn't go anywhere. And then I'm going to use that formula I just wrote down in green. The a is x, so x plus, and the b is going to be 2. 8 is 2 cubed. And then we'll get an x squared minus x times 2 plus 2 squared, or plus 4. And there's our final answer. Let's do the same thing with example B. I start by looking for a GCF. Always look for the GCF first. And on this one, I can definitely take out an x, and I think we can take out a 3 as well. 57 divided by 3. Yep, 57 divided by 3 is 19. So I'm going to pull the 3x out front, and then I'm left with 10x squared minus 19x plus 6. I've got 3 terms here, so I have to choose trial and error or the AC method. And for this one, I would probably use the AC method just because, well, first one is a 10x squared, so it could be 10 and 1 or 2 and 5, and then the 6 could be a 1 and 6 or a 2 and 3. I think the guess and check might actually take a while. So if I'm going to use the AC method, let's see, 10 times 6 is 60. So I need to find 2 numbers with a product of 60 and a sum of negative 19. So I'll just make a list. 1 and 60, 2 and 30, 3 and 20. Does 4 go into 60? Yep. 4 and 15, 5 and 12, 6 and 10. Oh, and I actually bypassed it right here. The 4 and the 15, if I make both of those negative, that will definitely add up to my negative 19. So I'm going to copy down the first term, and then I'm going to write down a minus 4x minus 15x, and then plus 6. So first 2 terms, we'll pull out a 2x, and we're left with 5x minus 2. And then in the second 2, I'm going to take out a negative 3. And now I'm left with 5x minus 2. That's a good thing. I can pull the 5x minus 2 out front. I'm left with a 2x minus 3. And then finally, I can't forget about that GCF. That's going to be part of my final answer. And so there's my final answer. 3x, 5x minus 2, 2x minus 3. All right, last one. We're going to start the problem by looking for a GCF. We can take out an x in this one. So if I pull out an x, I'm left with x minus 9. I have 2 terms. We can only factor 2 terms if it fits into a pattern. And because I don't have an x squared, this is not a difference of squares. This is it. This is my final answer. I actually can't go any further with this one. It's not a difference of squares or a difference of cubes. All right, that's it for lesson 10. As always, let me know if you have any questions.